Hello, welcome to our presentation. This is Jumping Jacks. We will cover a few points throughout this presentation. First, we will review how the movement is performed and what is required. Then we will look at injury and how that produces unideal movements. And last, we will discuss some research that pertains to jumping jacks, and we hope you enjoy our presentation. Here's a photo. We won't discuss this photo right now, but it does pertain to our research later, so we will move on to the next slide. This slide also pertains to our research in discussing how full body exercises help those who are less fit and how it helps them to engage in physical activity. Jumping jacks are very common, and you have all probably performed jumping jacks in your lifetime. A very common movement and very comfortable movement probably for most people, so it does help those engage in movement. But we do want to know what exercise you learned as a child that you remember. So just as you're asking us any questions at the end of the presentation, let us know what movement you learned as a child. So ideal movement. We're going to jump right into it. We have divided jumping jacks into 4 phases that we think are appropriate in terms of muscle utilization and joint action. So the first phase we have is going to be a person bending their knees, bending their ankles, bending their hips, squatting down, getting ready to jump up and out. So that second phase is where we see the person explode up, they jump up, spread their legs apart, and then we have that moving their arms above their head. The third phase we can see is they fully elevated their arms above their head, they've landed, squatted down again, getting ready to jump again, explode up. So we have that, and then we have that fourth phase, which we can see they've exploded up, they bring their legs together, arms to the side, and they land, getting ready to repeat phase 1 as many times as they need. As you can see, this is phase 1 of the upper extremity. We did decide to split the upper extremity and the lower extremity into different slides to discuss separately, grouping the trunk and neck into the upper extremity. So for phase 1 of squatting and down, primarily the movement is going to be in the lower extremity, so all there is to note for this is the muscles in the trunk, and which is just going to be an isometric contraction. All we want from the trunk is to keep us in an upright position and to stabilize us and absorb force to keep the core nice and tight as we perform the exercise. So we have the muscles, the abdominal muscles and the back muscles keeping us upright. As we move down into the lower extremity of phase 1, we start at the hip. We first have a hip flexion, which is going to be a concentric contraction, decreasing that joint angle from our leg to our stomach. We're going to be using those anterior muscles. We do see muscles like the sartorius, which run more medially, but generally anterior muscles we have, like the iliopsoas, quadriceps femoris, pectineus, the adductor longus. The next joint we have is the tibiofemoral joint, which is performing knee flexion. This is also going to be an eccentric contraction. If we had a concentric contraction of knee flexion, we'd most likely just fall over backwards. As we want to control that movement, we are going to be using our knee extensors, which are going to be the quadriceps femoris, those 4 muscles. We do also have the patellofemoral joint. We have the quadriceps muscles pulling on that tendon, causing the patella to upward and downward rotate in the condyles of the femur. We also have the talocrural joint of the ankle. As we squat down, we're going to be moving the knee over our toes, which is going to be causing dorsiflexion of the ankle. This is going to be an eccentric contraction. Again, we want to control that movement because our leg is moving forward and downward, so we want to control it. So we're going to be using the posterior muscles of the calf, the gastrocnemius, soleus, plantaris, those muscles. And then as far as the joints go of the foot, we aren't using any joints here. but we will see movement in phases to come. Here we've added a photo demonstrating phase 1 of jumping jacks. We see no movement in the upper extremity, we see anatomical position, but in the lower extremity we see the movement happening. We see that knee flexion, we see ankle dorsiflexion, a little bit of hip flexion, and we will move on to phase 2. All right, as we look at upper extremity phase 2, this is jumping up, spreading our legs apart, and raising our hands and our arms over our head. For the trunk, again, we just have a stabilizing isometric. We have those a little bit more spelled out as far as muscles go. We have that rectus abdominis, transverse abdominis, we have our obliques, and then we have our back muscles, the erector spine, etc. We also see the scapula and shoulder joints. We have that scapulohumeral rhythm. So as we abduct our arms, we're going to see that upward rotation and elevation of the scapula. Which, for the scapula, we're going to be using those serratus anterior, the trapezius, levator scapula. As you notice, we do have some muscles bolded, some not. We're just showcasing the muscles, and the bolded ones are going to be the ones we're using. It's going to be a concentric contraction. For phase 2 of the lower extremity, first we'll take a look at the iliofemoral joint. In red, we have hip extension, which is going to be basically phase 1 of phase 2. So we're going to be using those posterior muscles, the gluteus max, biceps femoris, those hamstrings, concentrically to explode us out of our lowered state from phase 1. And after we've extended our hips, we're going to then abduct the hips, abduct the hips, which will be using those lateral muscles, which are gluteus minimus, medius, and the tensor fasciae lata. These will both be concentric contractions. We have the knee joint, which will again be utilizing those extensor muscles, this time concentrically as we come out of our squatted position, again using anterior muscles, those quadriceps femoris. In our ankle, we see plantar flexion as we push up onto our tippy toes using those posterior muscles of the calf. We have peroneus longus, brevis, gastrocnemius, soleus plantaris, tibialis posterior, all those muscles in the back, even the ones that help flex the toes, like flexor digitorum longus. And again, this is going to be a concentric contraction. And then in the toes, we do see some toe extension at the metatarsal phalangeal joint using extensor digitorum longus and hallucis longus. And we do see that just at the metatarsal phalangeal joint to help us get onto our tippy toes but still maintain some balance. Here we have 2 photos demonstrating the 2 parts of phase 2. First, we can see that the hips are extended, knees are extended, and we see some plantar flexion, and we do see that extension of the metatarsal phalangeal joint. And then in the second picture, we see that abduction of the arms and elevation and upward rotation of the scapula. For phase 3 of the upper extremity, we have no movement and isometric contractions across the board. We have left all of our muscles in the same position they were in from phase 2, and will then move them in phase 4. For phase 3 of the lower extremity, we're going to be seeing a lot of the same movements as phase 1 as we come into that squatted position. We have hip flexion, those anterior muscles concentrically contracting to pull us forward, decreasing that angle. We have knee flexion, controlling that descent eccentrically. We have ankle dorsiflexion, an eccentric load, as we land our tippy toes, controlling that descent of our ankle to the floor, and then our knees over our toes, using those posterior muscles again. And then we have our metatarsal phalangeal joint, again doing the same thing as we land on our tippy toes, helping control that descent as we place our heel on the floor and disperse that force from going up to our knees. So here we can see a summary of phase 3. We have that isometric contraction of the upper extremity. We see that the arms are held above head as we land, and then we see those legs abducted. But again, we see, as in this phase 1, we have our knees flexed, hips flexed, and ankles dorsiflexed. So for upper extremity, phase 4, we're going to be seeing a complete 180 of phase 2, all opposite movements as we bring our arms down into our sides. For that scapula, we're going to be seeing downward rotation and depression. Again, these bolded muscles, we have pectoralis minor, the rhomboids, the lower portion of the trapezius. As far as our shoulder goes, we have adduction. We've got that pectoralis major, latissimus dorsi, teres major, and then we have those 3 rotator cuff muscles, excluding supraspinatus. We have infraspinatus, teres minor, and subscapularis. For the elbow, we're going to be seeing that extension. We've got triceps and the anconeus. And for our forearm, we have pronation. So pronator teres, pronator quadratus. And then for wrist and fingers, we have those, no movement for those, as those are just stable. But as you can see, again, we had concentric movements in phase 2, and we have concentric movements in phase 4 as well. And that's due to the high rate of speed and force that we are moving our arms to our sides. If we did have some external force in our arms that was heavy and we were slowly lowering our arms, we would see an eccentric contraction using the same muscles as phase 2, but since we are moving our arms so fast in a downward direction, we do see concentric movements as well. And lastly, phase 4 of the lower extremity. We're almost there. Looking at that iliofemoral, we have the same thing for the jumping up. We're going to have that extension of the hip, gluteus maximus, biceps femoris, same thing as phase 2. But this time we're going to be adducting the hips. We're going to be having those medial muscles, adductor magnus, gracilis, brevis, and longus. We got the pectineus, and these are going to be a concentric contraction as well. We have the same movement of the knee. We've got that extension exploding us out, the ankle again, and the metatarsophalangeal joints, both in toe extension and plantar flexion, helping us get onto our tiptoes and then exploding into the air. And lastly, we have an overview of phase 4. We see that we've exploded up as in phase 2, but this time we're bringing our arms down. And in the second picture, we see our arms fully adducted and our legs fully adducted as well. So now that you guys have finally made it through the overview of how jumping jacks are performed, we're gonna go over a much briefer section of how injury can affect jumping jacks. So as we've seen, jumping jacks do recruit the entire body to be in action. So therefore, injuries affecting any part of the body can affect how we do jumping jacks. Looking at the lower extremity first, we do see in the upper left-hand corner someone experiencing ankle pain, but really anywhere in the lower extremity can affect how jumping jacks are performed. If we sprain an ankle or we pull a hamstring, or even that patellar maltracking we've talked about in class, where one of the muscles on the side of our leg pulls sooner or harder than the other muscle, causing that patella to fall out of the groove. Any of these injuries can cause compensation to the other side of the lower extremity because of pain or weakness, and by doing so, that's going to cause muscular imbalances. It's going to cause leg length discrepancies. It's going to cause joint issues, and we don't want that. Also, looking at the trunk, things like a pulled muscle or a herniated disc can affect how someone does jumping jacks. As we see in the photo, we do see that nucleus, kind of coming out of the spine. But things like these issues are going to cause problems like individuals not being able to stand up straight, which is going to cause us to put our joints in compromised positions to either take loads or to create movements. As we see in the shoulder, if we are in a hunched position, that's going to cause a compromised position of our joint when we try to abduct our arm fully, which can cause increased strain and wear on our muscles in the rotator cuff, like our supraspinatus. Also, it's going to, if we're hunched over trying to do movements that create force, that's gonna cause force to travel inappropriately through our spine. So that's not good either. Also, looking at the upper extremity, I briefly mentioned rotator cuffs, but if we already have a damaged rotator cuff, by doing jumping jacks and abducting our arms fully overhead, this can cause more tearing and even full separation of the rotator cuff muscles. It's also going to cause muscular imbalances if we're only using one arm to do jumping jacks, or even disturbing the force generated by the limbs doing jumping jacks. And finally, we're going to look at some of the research that's been done on jumping jacks. So here we have our article summary, but the article is on jumping jacks and heart rate variability. Now, this is the picture we saw from the first slide. We see make the jump. What we are is over on the left, and we got to take that leap of faith, what we want to be. This article does describe how jumping jacks are used in full body exercise programs and heart rate variability. We see more and more people becoming inactive and not meeting the recommended daily exercise goals. And we do see, these full body exercise like jumping jacks. We see it improve people's fitness. We see it improve heart rate variability, because of the things we've discussed with the jumping jacks, including so many muscle groups into the action that we perform. In this next slide, we do just see kind of a reiteration of the previous slide. Like it says, those who did not participate in the exercise had no change in the resting heart rate, whereas those who did participate in the exercise showed a decrease in resting heart rate and that improved heart rate variability, a healthier heart. So in conclusion, simple 10 minutes of this exercise, including jumping jacks, can improve your fitness. Here is a slide of just the references that were used for the research. Big thanks to Lindsay for doing the research for this last part of the slide. But we're glad that you listened to our presentation, even though you had to, and ask those questions away, and we'll answer those questions. And thank you so much for listening.